Hello. Today, let's see where we are. Let me ask you the question. Do you feel confident that you could solve each of these equations? Based on last night's homework, could you solve this one? Okay, here's how you do it. You take the square root of this and the square root of this. You end up with m equals 6 or m equals negative 6. Can you do that? I hope yes. Could you solve this one? Let's do that one the same way. Let's take the square root of both sides. Okay. You end up with m plus 1 equals 6 or m plus 1 equals negative 6. Then what do you have to do? You have to isolate m, of course, so we subtract 1 from both sides. Same thing over here. And you end up with m equals 5 or m equals negative 7. So hopefully you feel confident with that. Do you feel confident with this? Maybe not. This is one of the things that we have to learn to do today. Okay? Please recall, what is this kind of equation called? Yes, it's a quadratic, but it's a special quadratic. What is it? Well, notice that it has two parts that are, hold on here, let's do it this way. It has two parts that are perfect squares. This is a perfect square, and this is a perfect square. Let me show you something else. This part in the middle, think of it this way. If we split that part right in half, think of our area model we talked about earlier this year. If you put x squared here, split that 14 into 7x each, and 49, can you factor that? Yes, you get x plus 7, x plus 7. It becomes x plus 7 squared. This is a perfect square trinomial. Does that ring a bell? Take a look in the middle. How do those two numbers relate to each other? Well, they're both divisible by 7. This one is 7 squared. This one is 7 times 2. All right, let's keep going here. Take a look at these equations. Which one does not belong? Hopefully you're thinking about it. This is the one that does not belong. Why? Because this one is not a perfect square trinomial. Take a look at this slide. Do you know these are the same equations? What do you notice about each of those? These are algebra tiles. Let me show you something. Can. Okay. Hopefully you notice, first of all, that this one is not a perfect square trinomial because it's missing some dots. How many dots would it need to be a perfect square? It would need 4 more. It would need a total of 9. Okay. Question. What does this stand for? This is our x squared. What are each of these blues? Each of those blues is an x. Okay. Could those blues be negative x? Yes. Over here, we have negative 12h. Those could be negative h as well. Okay. How about the red dots? Those are circles. So of course they're circles. Those are the units right here, and we have 25 of them. Okay. Remember how we were talking about the area model just a second ago? Let's go back to that area model again. Okay. Notice how our area model is just the same as the algebra tiles. We put x squared right here. We've got 25 down in the corner. Notice x squared, 25. What do we do with the 10x? We split them right in half. 5x, 5x. When we factor, we end up with x plus 5, x plus 5. That's x plus I'm probably only going to do one of these, but watch what you could do. Okay? I just saw that this is a perfect square trinomial. Notice again the difference between here and here, the second term and the third. 6 goes into both of them. This one is 6 squared. This one is 6 times 2, but with a negative. So I can say that this is the same thing as x minus 6. It's not x, it's h. H minus 6 squared equals 144. Now I could take the square root of both sides, right? I would end up with h minus 6 equals 12, or h minus 6 equals negative 12. Okay, what do we do next? Well, we have to isolate h. So we add 6 to both sides. We end up with h equals 18, or add 6 to both sides, h equals negative 6. You see how we solved that? All right, let's move on. Okay, how do you feel about solving this equation now? Do you recognize that this is a perfect square trinomial? This is m plus 1 squared. Same thing as this. So hopefully now you feel, yes, you can solve that. Okay, this is from the homework. So let me show you a couple things. The goal here is to turn x squared plus 6x into a perfect square trinomial. And how do we do that? Watch. I'm going to use algebra tiles to make a picture of what's going on. We've got x squared. Instead of drawing a rectangle, I'm just going to use a line. These are my x's. I split that 6x into 2. So I've got 3 x's in each direction. Now, how many dots do I need to complete the square? Imagine that each of these lines is coming out, and where they intersect, there's going to be a dot. Can you see that I need 9? Yeah? Okay. So here's what we do with symbols. We say x squared plus 6x. And now instead of c, I'm going to write plus 9. And that's the same thing as x plus what? X plus something squared. Well, can you see on the side here? This would be an x. This would be a 3. This would be an x. This would be a 3. Or if you want me to do it with numbers, I can do it this way. Area model. X squared, 3x, 3x, and 9. Can you see that this becomes an x? Sorry. Let's try that again. This becomes x, 3, x, 3. So you end up with x plus 3 squared. How does the x relate to x squared? How does the 3 relate to 9? How does 6x relate to x and 3? All right, I'm going to leave this one for homework. You guys try this one. Try it on your own, then watch my work. Okay? This is my x squared minus 4x. How many dots? I need 4 dots. So this becomes x squared minus 4x plus 4. It's plus because negative times negative becomes positive. And when we factor it, it becomes x up here, minus 2, x minus 2, x minus 2 squared. Okay. I'm going to leave this one for homework. Let's try this one. Try it on your own, then compare to me. X squared plus x. We divide that 2x in half, leaves 1 dot. So we end up with x squared plus 2x plus 1. That becomes x plus 1. Do you see it? X plus 1, x plus 1 squared. All right. pink one down here. This one is really hard to make a picture of. So we're just going to use the same pattern that we had before. We had x squared plus bx. Now, how do you find c? Well, before we took half of this and then we squared it. So let's take half of b, 1/2 b, and then we'll square it. 1/2 of the middle term and then square it. Okay, we're going to skip these for now. Okay, on your homework, I can't remember what number it is, but this is one of the homework's numbers. Let me show you how to do this. And here's the first step. I'm going to kind of change these steps just a little bit. I'm going to look. I know this is not a perfect square trinomial because this is not even a perfect square. So my first step is to move these 12 to the other side. X squared plus 4x equals negative 12. Good? Now I want to change these terms into a perfect square trinomial. So let me go down here. Oh, here's what I'm going to do. I'm going to do x squared plus 4x. I'm going to add a number equals negative 12. But if I add a number to one side, I better add that same number to the other side to keep them even, so it's still the same value. So let's go down here and draw a picture of how we can complete this square. We've got an x squared. We split those 4x like this, you end up with 4 dots. So we're going to add 4 here and 4 here. Okay, what does this pattern become? That becomes x plus 2 squared equals negative 8. You see where the x plus 2 comes from? X plus 2, x plus 2. All right, let's try another one. Again, this is one of your homework problems. I can't remember which one though. First step, I know this is not a perfect square trinomial. Let's get rid of the 21x. Sorry, let's subtract 21 from both sides. X squared plus 12x equals negative 11. Okay, now I'm going to complete the square on this side to turn it into a perfect square trinomial. X squared plus 12x plus some number equals negative 11 plus that same number. What number should we add? Try and figure it out yourself. Then look at what I did. We've got x squared. We split that 12x in half. How many dots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do I have to make all the dots or can you figure it out? How could you figure it out? It's going to be, I've got 2 more rows. How many dots do I have altogether? Well, I've got 6 times 6. What's 6 times 6? 36. So I add 36 to both sides. And I end up with, what numbers go in here? I've got x plus, because this is a plus 6. Do you see how that 6 relates to the 36? X plus 6 squared equals, what's negative 11 plus 36? I think it's 25. All right, let's try another one. Let's do this. I know this is not a perfect square trinomial. Let's subtract 30 from both sides. You end up with x squared minus 14x equals negative 24. Okay? Now we're going to complete the square. Negative x squared minus 14x plus some number equals negative 24 plus that same number. Let's figure out what that number should be. This is our c. Okay? It's going to be x